will you please make sure your name is on your notes so that they can get back to you if they should be lost? Yeah. All right. Should probably gonna send an email to your parents to say, hey, their binders should be cleaned out, and she might need new supplies. All right, this is rotated around. That's really annoying. Okay, so today we're talking about systems of equations, and this whole unit is systems of equations. And basically, a system of equations is two or more equations. Two or more equations in the same variables. So we start off with two equations and two variables. So we're going to be starting with x's and y's. But as you get older and able to do harder things, we're going to see that there's equations with three variables, x, y, and z. And in fact, that there's a whole field of math called linear algebra, where we solve equations with 10 variables, 15 variables. But what we have to understand is if we have two variables, I have to have two equations. If I have three variables, how many equations would I have to have? 3 equations. And if I have 15 variables, I'd have to have 15 equations. All right? But believe it or not, math allows us to solve these things, and it's kind of cool. So we're starting with two equations and two unknowns. And the solution to the system graphically is the point where the two lines intersect. And that's where we're starting with. It's the point that our two equations have in common. And so we're going to start today by graphing the equations that we're going to see. Where do they intersect? Where do they cross? And that's going to give us our answer. Algebraically, so when we do it with the algebra methods we're going to learn, it's the point, x, y, that makes both equations true or balance. All right? It's the x and y values that make the equations balance. But we're starting with graphing. So here's what we're going to see. We have a couple of different types of solutions we can get. First, we might have a line that goes this direction and another line that goes like this. So we have two lines that we're going to graph, and the solution is where they overlap. So we get one ordered pair with an x and a y coordinate. So that's what we're looking for. Where do they intersect? And you'll see that many times today. So there's some ordered pair where they cross. But maybe I have one line that goes like this, and I have a second line that goes like this. So here's my two lines. Do they intersect? No, they don't. So do they have a solution? No, they don't. There is no solution because what kinds of lines are these? Do you know that word? Parallel. Very good. They are parallel lines. What does parallel mean? They never cross. They won't intersect, so we can't have a solution, okay? So this one, we would write there's no solution because of parallel lines. They're never going to intersect. But also, we could have, hey, here's a line. And then I have a second equation. Hey, and they graph. They're the exact same line. So how many times do they intersect? All the time. they're stacked right on top of each other. How many points in common do they have? All of them, right? And so that's when we get infinite solutions. Infinite solutions, I'm going to do B/C. Do you know what B/C stands for? Because, this is shorthand, all right? Because they are the same line. So we get infinite solutions because they're the same line. They overlap all the time. So there's a billion different solutions they have in common. And I just want to make sure that you're not looking at your computers because you should be paying attention to notes. All right. Okay, so a couple of examples here, just to get started and sort of refresh our brain here. I have two lines, and we're going to write the system of equations and identify the solution, which is kind of a review. So if you remember from our last unit, we had y equals mx plus b. This was slope-intercept form. The m was the slope, and the b was the y-intercept, or the begin point, where we would begin graphing the line. And what we're going to do is we're going to write our equations first. And so I want to write the equation of this line and this green line that I'm highlighting. Where does it begin at? Yeah, it begins right here at 2 on the y-axis. And I need to figure out its slope. So to go from my point 2 to this other point that we have here, what's our slope? Up 2 and over how many? Over, it looks like 3. 1, 2, 3. The printers were running out of ink. All right, so I have an equation for this line. That would be y equals, what's our slope that we found? 2 over 3, with an x, and plus, what's our beginning point? 2. That's where we began on the y-axis. Perfect. So there's one equation. Now I want to do this other equation here. This is the pink line that I'm drawing here. And again, I want to find the equation for it. So where does this pink line begin? 1, 2, 3, 4, 5. Good. -5. It begins at -5. And again, I need to figure out the slope here. Oh, you know what? I don't want to go all the way to that point. Look, it crosses real nice right there. So let's try to get to that point. How many up is that? 3 up and over 1. All right. So we get y equals, what's our slope? 3 over 1. Rise over run, so 3 over 1. Don't forget your x. And then where does it begin at? -5. All right. Ladies and gentlemen, congratulations. You just wrote your first system of equations. So this is your system that produces this graph. And where is the solution? Where do the pink and green lines intersect at? What is that ordered pair there? 3, 4. Yeah, over to the right 3 and up 4, and that's our solution, 3, 4. So 3 on the x-axis and then up 4. All right, fantastic. So you actually don't have to write the equations, which is nice. So instead, we are going to be graphing them. So we're going to turn the page. Okay, so to solve a system by graphing, step number 1, to solve, we want to make sure, get equations into y equals mx plus b form. So we did a lot of that in the last unit, getting the y by itself. We want to be in this slope-intercept form because it's super easy for us to graph. So then we're going to graph, G-R-A-P-H would be better. Graph each, oh my goodness, I can't write today. Each line carefully. And I'm going to be pretty particular about this. Graph each line very carefully. And then step 3, find the solution. Find intersection. And also remember that you can check your solution, which we'll talk about too. Okay. So we're going to practice here, doing a lot of graphing and solving. And if you have 2 colors, I highly recommend having 2 colors. I'm going to graph with 2 colors. You could do a pencil and a pen. That would be fine. But I have 2 equations here. Are they in slope-intercept form? Yeah, we got the y equals mx plus b, y equals mx plus b, y equals mx plus b. So they're both in slope-intercept form. And so I'm going to start, I'm going to graph this top equation with my pink mark pen. And where should I begin? What is the b? And what's the slope? 4 over 1. I love how you turned that into a fraction for us. That's brilliant. All right, so this says we're going to begin at 1 on the y-axis. So we always put a nice big beginning dot there at 1 on the y-axis. And then what does my slope of 4 over 1 tell me to do? Up 4 and right 1. So from my beginning point, I'm going to go up 1, 2, 3, 4, and over 1. And I'm going to do it again. Up 1, 2, 3, 4, and over 1. Now, because we're graphing by hand, I want to be really sure of where my points are. So I'm actually going to do a full Uno reverse here. And I'm going to go down 1, 2, 3, 4, and left 1. Because I really want to be know exactly where my line is. 1, 2, 3, 4, left 1. So I'm going to make sure my first line I graph fully. And now I can go ahead because I have really clear points. Connect the dots. So there's my pink line. Now I think you guys are doing this in Delta Math, so it's nice it'll graph a perfect line for you with just 2 points. But by hand, we want to be extra careful, okay? Now my second line here is also in slope-intercept form. Where do I begin? What's my b value? -5. And what's my slope? -2 over 1. I love how you turned that into a fraction again. So we're going to begin at -5. 1, 2, -3, -4. Right here is -5. So put a nice big beginning dot there at -5. And then what does my slope of -2 over 1 tell me to do? Down 2, right 1. I'm going to go down 2, right 1, down 2, right 1. And again, full Uno reverse, which means I'm going to go up 2 and left 1. And ding, 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 ding. I just intersected my line, didn't I? So now I'm going to go up 2, left. Okay, so there I can connect my green dots now. And I can clearly see my point of intersection right here. What is that ordered pair? -1. We had to go left 1 and then down 1, 2, 3. -1, -3 is that point right there. So my solution is -1, -3. Now the nice thing is, and I'm just going to check this first one so you can see how it works. We can check because we're giving an ordered pair x and y value. And so we go back to our equations and we're going to plug in. What am I going to plug in for y? The y has the value of -3, so that's going to go in there. -3. And then 4, what goes in place of the x? Yeah, the x has a value of -1. And then I have my plus 1. And so what I want to do is just check here, this right-hand side, 4 times negative 1 plus 1 gives me, hey, that's negative 3. And you see, we get negative 3 equals 3. Is that true or false? It's true, right? So that first equation works just fine. It balanced perfectly. We also have to check the second equation because it has to work for both. And so again, I'm going to go to my second equation. Again, what goes in place of the y? Negative 3. And then I have a negative 2 times my x value. My x has a value of negative 1. And then I have my minus 5. And I'm just going to type that whole thing into my calculator. Negative 2 times negative 1 minus 5. And I get negative 3 as well. So that one also balances perfectly. Okay? So we know we did it perfectly correctly. You can check every single problem. All right? Which is really, really nice. Let's graph some more, ladies and gentlemen. Let's look at number 2 here. Is it in slope-intercept form? Yes, it's in y equals mx plus b, y equals mx plus b. We're in perfect form. Where do we begin? 8. And what's our slope? 5 over 2. Good. So I'm going to start at 8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. So there's my beginning point right there at 8. Ooh, 5 over 2. Normally I would go up 5 and right 2. 1, 2, uh-oh. That makes it a little challenging. I'm off the map here. What should I do instead? Down 5 and left 2. Uno reverse, full reverse here. So we're going to go down 5. 1, 2, 3, 4, 5, and left 2. 1, 2, 3, 4, 5, left 2. And I'm going to keep going, particularly this first line. 1, 2, 3, 4, 5, left 2. And that's about as far as I can go. So there's my first line, my pink line. All right, my second equation is also in slope-intercept form. So where do I begin for that one? What's my beginning value? Negative 8. And my slope is negative 1 over 6. So again, I'm going to put the negative with the top number, and that tells me to go down 1 and right 6. So we're going to be careful. We're going to start at negative 8. 1, 2, 3, 4, 5, 6, 7, negative 8. And it said go down 1 for the slope and right 6. 1, 2, 3, 4, 5, 6. But I need to go full reverse. So I'm going to go up 1 and 1, 2, 3, 4, 5, left 6, and ding, 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 I found my intersection point. All right. All right. Ladies and gentlemen, what is this ordered pair where they're intersecting? Negative 6. Negative 6, negative 7. All right. Okay. All right, ladies and gentlemen. Let us do one more of these. Will you please try number 3? I'm going to give you a minute to start working ahead. On this first equation, which is in slope-intercept form, we have, where do we begin at? Is it? Oh, positive 5. It's a positive 5. And then what's our slope? 1 over 1. There's a number missing, but there's always a 1. So that tells you to go up 1 and right 1. So try number 3. Lots of dots for that first line. That first line, super important. The second line is much quicker. All right. Very good. All right, 1, 2, 3, 4, 5. I'm seeing very good dots. First one's a doozy. There's that first line. You should have a match. Whoa. Oh, it's more than that. I mean, yes, it's coming off the trees, but that's crazy. Okay. All right. And then -7 for my green line. 1, 2, 3, 4, 5, 6, -7. Don't forget to give yourself your starting point there. It's always important to have a place to start. And from there, we're going to go down 3 and right 1, 1, 2, 3, right 1, which then, of course, I need to reverse. Up, 2, 3, left 1, up, 2, 3, left 1, up, 2, 3, left 1, right there, ding, 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 I found my intersection. All right, ladies and gentlemen, what is that solution point? -3, 1, 2, -3, and then up 2, very good, -3, 2, all right. Give me a thumbs up. How are you feeling about graphing these lines? Okay. All right, good, good, good. Let's turn the page. Let's look here at number 5, because we've got a nice line here. Number 5 is my equation in slope-intercept form. Yes, the y is by itself. We got it. Looks like y equals mx plus b, because that's what we're looking for. All right, so our b is 2, and our slope is 1/3. So go ahead and graph that line, starting at 2. And what does our slope tell us to do? Up 1 and right 3. Up and over, always to the right. So up 1 and right 2, 3. Who are you looking for? I'm sorry?
Jenna.
No.
She's not here.
I think. Jim, new schedule. Yep. Yeah. Oh, okay. All right, let's see. And then up 1, right 1, 2, 3. And I can go the other direction. All right. So there we have a beautiful line. I missed my point, but that's good enough. Okay. Look at that second equation, x equals 9. Whoa, that is crazy. What's going on there? X equals a number. Don't have to add a 0. This is a special case line. X, what is it? What are we thinking? No? Special case, it's horizontal or it's vertical? Which is it? Vertical line. Yes, this is a vertical line. X equals a number is a vertical line. We're going to go to 9 on the x-axis. That's what it's telling you to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And remember, we did these special case lines. Every x value is 9, and that's just a vertical line. Every single point on this line forever and ever has an x value of 9. So be careful, watch out for those special equations, all right? So x equals is a vertical line. Okay, where do they intersect? At 9 for the x value and up how many? 5. 9, 5. So our solution is 9, 5. Super. All right, we're going to just do one more. I'm going to have to adjust the assignment. See, I never know how long this is going to take, so I'd rather take the time because it's so important. Okay. Number 6 here, are we in slope-intercept form? Yeah, for the first one, we are slope-intercept form. Y equals mx plus b. Where do we begin? -5. What's our slope? 2 over 1. 2 over 1. Up 2, right 1. Up 2, right 1. So we're going to start at -5. 1, 2, 3, 4, -5. And then we're going to count our slope up 2, right 1. Up 2, right 1. Up 2, right 1. All right. I think I've done enough there. Nice big line there. Beautiful. There we go. All right, what about our second equation? Y equals 2x plus 0. Very good. Yeah, there's something missing there. We can fill it in with the placeholder of 0. So where are we going to begin? At 0. And then what's our slope? 2 over 1. And again, we're going up 2 and right 1. So I'm going to begin at 0 at the origin. And then from there, we're going to count up 2 over 1, up 2 over 1. Hey. Do these lines intersect? They are parallel. So no solution because parallel lines. I like to always write out this statement. It's no solution because we have parallel lines. It's going to connect a lot more brain wires in there later on for us. There is no solution. They don't cross anywhere. They have nothing in common, so we don't have a solution. Ladies and gentlemen, do you have questions for me? Okay, we're going to pause there.